talking with Dr. Robert Tauxe of the CDC. Dr. Tauxe, how many people get sick every year from contaminated food?
We estimate that about 1 in 6 Americans get sick every year. That's 48 million in all.
And are there usual suspects from the food?
There are many different foods that can cause foodborne illness. They include lots of fresh produce items, poultry and meat items, dairy and eggs, and seafoods. Mm-hmm. The largest number of illnesses come from produce, and the largest number of really serious infections that might be fatal come from meat and poultry.
And what foodborne illnesses are on the rise?
We are seeing increases in certain types of salmonella. We're seeing increases in the Vibrio infections that come from seafoods. And we're seeing other infections that used to be on the way down and have sort of leveled off.
Such as?
Like Campylobacter. Infections like Campylobacter, Listeria, E. coli 157 have not decreased much in recent years until just this last year when E. coli 157 started dropping again. Most welcome.
Tell us about Vibrio. What does that come from?
The Vibrio infections are related to water, and particularly the waters that shellfish and other seafoods are harvested from. Undercooked or raw shellfish are the usual source of Vibrio infections.
And why do you say everyone in the U.S. should be vaccinated against hepatitis A?
Well, hepatitis A is a general problem around the world. It's transmitted amongst young children particularly, and very rarely these days also among food. Our general recommendations are vaccinating children against hepatitis A is part of the routine suite of vaccinations.
And explain the emergence of DNA sequences of bacterium and why that's important.
In our public health surveillance, we have used the tools of microbiology to fingerprint bacteria that make people sick. It's almost forensic. If we can get the same fingerprint from bacteria from 2 different people, it suggests those bacteria had a similar source. How we compare bacteria using molecular techniques is rapidly advancing. In the most recent years, since 2013, we have been testing whole genome sequence. That is, reading out the entire DNA code for a bacteria and comparing that across the bacteria that make people sick. And there's a lot of variation, and it lets us make very precise determinations. This person's illness is caused by a bacteria that is darn near identical to an infection in another person. They almost have to have something in common if we can figure out what that is.
All right, thank you very much.